Have you ever wondered how electricity flows in strange metals? Well, prepare to dive into the enigma of these peculiar materials known as strange metals. These aren't your everyday run-of-the-mill metals. They're a type of quantum material that cheekily snubs the rules of electrical resistance that regular metals adhere to. Imagine a metal that could become a superconductor, not at the bone-chilling temperatures required for regular metals, but at temperatures that are relatively high. Sounds like a science fiction fantasy, doesn't it? Yet that's exactly what these strange metals do. And here's another twist in the tale. The resistance of these metals increases not exponentially, but linearly with temperature. This is akin to a rebellious teenager who does the exact opposite of what's expected. Isn't it fascinating how these strange metals behave in such a peculiar manner? Now, what if I told you that electricity flows like a fluid in these strange metals? Indeed, in a recent groundbreaking experiment, scientists created nanowires using a blend of these enigmatic materials. They then observed the flow of electrons within these wires, utilizing a technique known as shot noise. You could think of shot noise as the sound of electricity, the rhythmic hum of electrons in motion, but in this case, the melody was anything but typical. The current arrived not in the expected steady rhythm, but as a continuous hiss, like the whisper of a distant waterfall. This suggested that the electricity was being carried through the wires in an out-of-step manner, akin to a dance where every participant moves to their own beat. This is a significant departure from what we usually observe in regular metals, where electricity flows smoothly and predictably like disciplined soldiers marching in unison. But in these strange metals, the electrons seem to be flowing more like a fluid, each taking its own unique path, yet collectively contributing to the overall flow. Such behavior contradicts our basic understanding of how metals and indeed electricity works. It defies the norms of electrical resistance seen in regular metals and hints at the possibility of strange metals becoming superconductors even at relatively high temperatures. It's as if we've stumbled upon a secret gathering, a hidden waltz of electrons, each dancing to a tune that we're only just beginning to hear. It's a performance that's mesmerizing, puzzling, and frankly a bit strange. This peculiar flow of electricity has left physicists baffled and intrigued. Our understanding of the world is always evolving, and every new discovery brings with it a new mystery to solve, a new dance to understand. This is the mystery of electricity flow in strange metals. You might be wondering, why is this discovery so important? Well, let's delve into the potential implications. Firstly, this unexpected observation could fundamentally alter our understanding of how electrical charge is carried. Traditionally, we've thought of electricity as a steady flow of electrons, much like cars on a highway. However, this out-of-step current suggests a different picture, more akin to a river where the water, or in this case electrons, flow more like a fluid. Secondly, it broadens our knowledge about the behavior of strange metals. Known for defying the rules of electrical resistance seen in ordinary metals, strange metals have always been a bit of an enigma. With this discovery, we're gaining new insights into their peculiar properties, which could lead to the development of more efficient electrical devices or even revolutionary technologies. Lastly, it's worth noting that strange metals can become superconductors at relatively high temperatures. If we can further understand and harness this property, the implications for energy efficiency and power distribution could be immense. Indeed, this discovery opens up a whole new realm of possibilities in our understanding of strange metals. So, what do we take away from all this? We've delved into the enigma of strange metals, these remarkable quantum materials that defy the rules of electrical resistance we're accustomed to in our everyday metals. This isn't just a minor deviation, it's a stark defiance. A linear increase in resistance with temperature, unlike anything we've seen before. We've also grappled with the mystery of electricity flow in these metals. It's not a steady march of electrons, it's more akin to a river, a fluid flow. And this isn't just a poetic metaphor. In a lab experiment, when scientists created nanowires from a blend of these strange metals, the current arrived as a continuous hiss. This suggests an out-of-step manner of electrical charge being carried, upending our understanding of how electricity behaves. This discovery, while puzzling, is significant. It's a step into the unknown, a peek into a new realm of physics that's waiting to be explored. It's a reminder that even in this age of scientific advancement, there are still mysteries out there, still more to learn, still more to understand. Who knows what other mysteries lie hidden within these strange metals? To continuously be enlightened, like and subscribe.